Okay, this is the recording for the third standard that we're talking about in the Unit 1 as summative evaluation. And that is F.LE.4. This standard specifically has to do with exponential models using logarithms. With this particular unit, though, we're mostly just doing the last part of that says evaluate a logarithm using technology. So it's quite simple and straightforward. And the main tool that's going to help you do this is Desmos. And so let me click over here to Desmos. You wanted to find the approximate. Oh, let me see. Let me go like this. I need to share my whole screen. Let's do the window. Oh, yes. Okay, yeah, we're going to share that whole thing. It's already being shared. We're going to come back to it. I need to open up Desmos over here. So if we did Desmos, and then just type this in. So this is my favorite thing. So we're going to do log. You can just type the word log on your keyboard, 0.3. If you didn't, oops, 0. I messed up on the typing of that thing up here, 0.3. If you don't have that and you want to use the keypad the whole time, switch this to that, you can. Also, you can go into functions, and I think logarithms are in there. I don't think so. Miscellaneous log is right there, but you can just type it. So the closest approximation for this one would be negative 0.523. I'll say that one. So coming back to what we had, I got this, I typed it in, and I got that right there. Okay, so we just type it in. This one, again, and I'm doing this one, this one's a nice one to do because it shows you the pattern for what to do with logs. That's not a calculator thing, but you can use a calculator. If I wanted to evaluate log base 5 of 125, one of the ways that most people would do it is they say, okay, well, that's going to equal some number. So let's take it out of logarithmic form and see 5 to what power would equal 125. So 5 to what power equals 125. And I know that that power has to equal 3. But this is going to help us by learning something called the change of base formula. Because the base would be that 5. This is the base. And if you just go into Desmos, like we just did, if you type in log, it's just assumed that the base is 10. So it's saying 10 to what power would equal 0.3. So if I actually did, let me just show you. If I did 10 to the power of negative 0.522, because we're trying to get 0.3, right? 5228787. See, in the more numbers I type in, you see it's getting closer and closer to 0.3, which is the thing that we wanted right there, right? So that's the idea, is it undoes that. When we have just log, it's base 10. So if we wanted to change the base, we actually have to do this formula. So the change of base formula. In the other video, we talked about how the base is always the lower thing, and it kind of follows that same rule. If I wanted to type into my calculator log base 5 of 125, I type it like this. I would do log of 125 in parentheses divided by log of the base. Because remember, that base is heavy, it's deep, it's below everything else, and it's going to stay in the denominator. How I could rewrite this is I could actually just take this log of 5 and make it a fraction. So log of 125 divided by log of 5. And then if I type that in, I would also get 3. And you can try that out on your own, which is really nice when you're doing things like this. So this would be the log, and kind of you can think of the bigger number, like the physically bigger written number is what stays on the top. And then this one that's in the bottom stays on the bottom. Log base 7. So 280, log of 280 over log of 7. So we can do log of 280. And then I'm going to close the parentheses because I want to divide by log of 7. That's equal to approximately 2.896, something like that. So we did the change of base formula. We're able to figure it out. And then this one, ln, is actually its own special logarithm. This is log to the base of e. E is a number that's kind of like pi. The number pi, which, you know, is pi like this. In fact, let me show you in Desmos. Oops, I went to the wrong way to get to Desmos. So let's clear this off. I'm on the wrong thing, that's why. There we go. So if I did natural log, so that is, again, if you want to do this thing, ln, the natural log of whatever. And I wanted to find out what e was. That's what it was, e. If I type in e, it's 2.7182818246, or 846. Anyway, kind of like pi. And pi, if you ever needed to type it, you type pi and it goes in there. So it's its own special number. I wish I had a better explanation of what e was, but it's really cool. It's kind of how it's what describes a lot of patterns in nature. And I will maybe put another video in somewhere. But e is its own base. So when we're saying the natural log, because it happens in nature, it's saying log base e. So log base e of 14. But then the nice thing is you can just type in your calculator ln of 14 and it'll find it for you. So we're going to go to Desmos and we're going to do there. So ln for the natural log of 14. And then there you go. So we got 2.639. All right. And that's basically, I mean, that is all you'll have to do for F.LE.4 in Module 1 Summative Assessment. So I hope you do well on it. And let me know if you have any more questions.